go ahead and turn to the endothermic and exothermic reactions page in your notes, and we're going to fill these out together. So we have to first define some terms. System is the part of the universe that we focus attention on. So it's the thing that we care about in a reaction. It's really the reaction itself. So in this picture, the system is what's happening inside of this. That thing is called an Erlenmeyer flask. It's what's happening inside of that flask. It's the water or liquid or whatever this blue thing is. That's the system. It's where the reaction is actually happening. The surroundings are going to be everything else. So if you look here, if the inside was the system, the surroundings now are all the outside things. It's the box, it's the air, it's this Erlenmeyer flask that the liquid is inside of, but it's not the actual liquid. The liquid was the system. Everything else is the surroundings. But when we combine those things together, the system and the surroundings, you get this universe. The universe is everything. All of the things together are the universe. In this picture, if you say your system is anything that is made up of water molecules, that's going to include this liquid water. It's also going to include ice. Ice is our solid water, right? But all of those are still water, just in different phases. Now the surroundings would be everything else. It's going to be the air in the cup. It's going to be the actual cup. Maybe this is sitting on a table. That table would be a part of the surroundings. Maybe somebody's holding this cup. That hand would be a part of the surroundings. Everything that is not a water molecule is the surrounding. So we have exothermic reactions. Exo, think exit. EX, EX. If something is exiting, it is flowing out of the system. So in this case, we're talking about heat energy. Heat energy flows outside of the system. Well, if heat energy is leaving the system, it must be entering the surroundings. And because heat energy is entering the surroundings as it leaves the system, it means that the surroundings actually feel warmer. And remember, when we are experiencing a reaction, you or I or your friend, we are all a part of the surroundings. So if they feel warm to us, it's because it's exothermic. In a chemical equation, that means that heat will be written as a product. You see it being produced, being released, it's going to be a product. Again, exothermic, exo, think exit. A common example is condensation. So remember that condensing is going from a gas to a liquid. Well, in order to go from gas, which is a really high energy phase, particles are moving super, super fast at high temperatures, into water. Rain is liquid water. To go from gas to liquid, you have to have lost energy. The water particles lose energy. So this is an exothermic process. Now you might say, it doesn't feel warm to me when it's raining. And it might not. But all that means is that it might have been a small amount of heat energy released, small enough that you or I can't feel it out in the rain. Or even more likely is that energy is being released over huge distances, right? There are days when all of Columbus, it's raining, right? So if the whole city is raining, that energy that's being released is being spread throughout the entire city. That's a lot of space, right? So we might not be able to feel that energy in our exact position, but actually energy is being released. So it's going to be slightly warmer than it was before it was raining. Let's watch this quick video of an exothermic reaction. So if we look at this, and I'll go back a little bit, we had a powder, something was added to it, but the end product was a fire. Fire is hot, right? It feels hot. If I went and stood near this, I would feel that heat. Well, remember, I am a part of the surroundings. If the surroundings feel hot, to me, the system lost energy, which means exothermic. If it feels hot, meaning if you see fire, it is always, every single time, exothermic. So fire, exothermic. Now let's talk about endothermic. Endothermic is where heat energy flows into the system. Surroundings are going to feel colder, endo means into, because in order for the system to gain energy, it has to come from somewhere. Well, the only thing around the system are the surroundings. So if the system got hotter, the surroundings must have gotten colder. What this means is that we're going to write heat as a reactant. Endo, think enter. Endothermic, enter. And then on the flip side, exothermic, exit. Endo, enter, exo, exit. Here's an example. This is photosynthesis, right? Plants take in carbon dioxide, water, light, heat, and they turn it into glucose, which is sugar. It's the food, and oxygen. Another example is cooking something. If I add heat to whatever I'm cooking, let's say I'm making breakfast. If I add heat, it changes those eggs. Those eggs take in that heat and they get cooked. But you're adding heat to that. We're going to watch 3 videos and we're going to talk about whether we think it is exo or endothermic. So this water is going to be really important, okay? Keep track of that water. You'll notice there was liquid water added. So it's about 21 degrees Celsius. That liquid water is sitting on the wood underneath this beaker. So this is really important. This thermometer is measuring the air. Now, think really hard about this. The air, is it the actual reaction, right? The reaction was the stuff inside the beaker. The reaction is the system. The stuff inside the beaker is the system. Everything else is the surroundings. The wood, the air, the water, all of those things are the surroundings. So if the temperature has suddenly dropped to, what does it say, -5, -6, it means the surroundings got colder. If the surroundings got colder, the system must have gotten hotter, right? And we can even see this because, let me keep playing it. Look at that. The liquid water that was here froze, meaning the liquid water lost energy as the energy went from the water into the beaker. Remember, the beaker is the system. The stuff inside that beaker is the system. The system absorbed energy, it went into the beaker, and it got really cold all around the outside of the surroundings. So this is endothermic. Let's watch another reaction. So there's a little bit of something added to get the magnesium to first catch, but now that it's reacting all by itself, it's going all by itself, you can see smoke, you can see fire. If you see fire, you have to think exothermic. Fire is exothermic every single time. Remember, it is the opposite of what we feel. If we feel hot, the system feels cold. If the system feels cold, it's exothermic. Here's the last one. We're going to watch some ice melt. Very thrilling. The really important thing here is to remember that if you were the person holding that glass of ice as it melted, that glass would feel so cold to you. You've all held ice before. It feels cold. But remember, you are the surroundings. What you feel is the opposite of the system. If you feel cold, the system gets hot. So this ice is absorbing energy in order to melt. To go from a solid to a liquid, you need more energy to take in energy. So this is very, very endothermic. Hope this helped. Hopefully we understand the difference between endothermic and exothermic now.